Hello, everybody. Welcome to CoinFund Q&A. Today we have Wayne and Glenn from Tierion. Welcome, guys. Thank you for joining us. Tierion's been around for a while, as far as I've seen. You guys have built a platform initially on top of Bitcoin. Now it looks like you've expanded to Ethereum. Wayne, do you want to kind of give an overview of what Tierion is?
Sure. So first, thanks for having me on today. I appreciate it. So Tierion started back in 2015. At the time, I was running a company that made marketing automation software, and we worked on a performance basis, which meant that our compensation was based on certain numbers that we would report to our customers and that our customers would report to us every month, such as things like percentage of growth of online sales or the number of leads generated. And we had a problem where we didn't trust each other's numbers. We needed, because there was always this little bit of a tension between us. And so I had this idea that said, hey, there's these proof of existence type things that were pretty rudimentary back then. What if we could find a way to do something like that at scale so that we could be able to solve this problem for version 5 of what was called SmartNet, the software we were building at the time? And we quickly realized that the idea and some of the technology that we developed, the vision for that and the potential for that was much, much larger than just adding a feature to our marketing automation software. So my co-founder, Jason, and I, who've been working together for 21 years, we decided that we were going to sell off parts of that business and wind it down and start up Tierion.
Cool. So what do you, more specifically, like what is the market that Tierion kind of serves? Like, where is that proof of existence going to be applied as you see it?
Gotcha. Okay. So we have so Tierion's been used by over 1,000 companies. And I'm going to probably the best way for me to explain that is to give some real examples of how people are using it. So for example, Philips was an early customer of Tierion. They're the world's largest manufacturer of industrial medical equipment. They used Tierion initially to collect data from MRI machines to create an audit trail of its maintenance, usage, and calibration history. That way, they would have non-reputable evidence, verifiable timestamp proof of all of that data that they were collecting. And that's important for, I think, for regulatory purposes. And there's a whole host of other things that we've done with them over the course of the year that followed that. Other companies have used Tierion to in use cases like collecting healthcare data. So if you're collecting clinical trial data, you need to be able to prove that you collected the data at a particular time and that it hasn't been modified since that time. And so they're using Tierion to collect the data and generate a proof of not only the data that comes in, but sometimes the provenance of how that data is transformed once it's being archived. There's IoT use cases. It's very broad. I mean, the idea of using timestamping that's trustless and globally verifiable, and using the blockchain as a trust anchor for things like identity systems and issuing something called verifiable claims, which is part of the work that we're doing with the W3C. It's very broad and applicable to many, many different industries. So we created a product that was very easy to use. The initial product was a software as a service product. Anybody could come to the website, Tierion.com, sign up, and within minutes, they'd have really great API and other sets of familiar tools that they could use to generate these chain point proofs. Now, that was really great for us because we got to see how thousands of companies would use the software. Big companies, small companies, consulting firms, companies like IDEO and Accenture and IBM. We just see them sign up and we'd reach out to them and say, hey, this is really interesting. Tell us about how you're using the technology. And we've been able to learn a lot. And over time, we've been collecting that learning and making our product better. And then about 8 months ago, we really started out on a new adventure to take what we started off as a software as a service product and really redesign it and re-architect it to be what we call like a global proof engine, a big distributed network that gives this global timestamping, trust anchor, data integrity capability across the entire world. And we're about to launch it.
So let's dig into that a little bit. So when you do this kind of anchoring in the blockchain, what is let's say I'm an auditor and I come back to that data that you've put into the blockchain. What is it that I see? It sounds like I see the time when that data was anchored in, and do I have a proof of like who did it as well?
If you don't necessarily have a proof, I'll turn it over to Glenn in a second. He can answer some of these questions because I hear him chomping at the bit over there. But you have a proof of the integrity and the timestamp of the data. And if you combine that with a digital signature, if you're signing the data before you send it to Tierion, you could in that digital signature is tied back to an identity system like Keybase, you would be able to prove who did it. So Glenn, here's your opportunity. Go ahead and tell us a little bit more about how all this works behind the scenes.
Sure. So maybe I can just review from the sort of end user's perspective what their experience is when you're interacting with a new service. So we provide a REST API where you can take a hash of some data, and you would generate that hash locally, say a SHA-256 hash, but we support all different types. You would take that hash and you submit it to an endpoint on our server, and we're going to accept that hash and immediately give you back something called a version 1 UUID. So this is a universally unique identifier, but it's a little bit different flavor of UUID because it includes a high precision timestamp embedded within the data of the UUID. So what you're getting back is this handle that allows you to retrieve a proof later, but the handle itself is timestamped. And we merge that UUID as well as some other external sources of information that are outside of our control into what's called a Merkle tree. And we build a Merkle tree which gets built up to the root of a Merkle tree, and this is just a hashing structure. And the tip of that hashing structure is what we will ultimately submit to our calendar, which is an internal lightweight blockchain. And then the data that's in that calendar will in turn be what's anchored to the public blockchains, to Ethereum and to Bitcoin. So there's a whole lot of processing that's happening behind the scenes, building up these trees of Merkle roots until finally they get anchored into a blockchain. Finally, all that data gets collected, and each hash that was originally submitted gets generated a proof, and we make that available via another REST endpoint or WebSockets, where you can retrieve that proof when it's ready has been generated. First, what you'll get back is a version of the proof that contains a linkage up to our internal calendar, and that happens within moments. So you almost immediately have something that's actually usable that anchors to a trust source, which is Tierion's trust source, but that calendar is actually bidirectionally linked to the other public blockchains throughout its history. So it actually incorporates a lot of the security properties of the public blockchains as well. Then shortly after that, as we go through the process of anchoring to the blockchains, which takes a while for us to get those confirmations, we will upgrade that proof at that endpoint. And within about an hour, you can retrieve back the full proof that contains both the Ethereum and the Bitcoin anchoring operations in that proof. So you would then come back and retrieve that proof. Now you have your original data, you have the hash of that data, and you have a proof that verifies that this data, this hash, is anchored and what time it was anchored. And these three things are the things that you would keep as a client. Maybe you keep them together in a database or on a file system so that at any point in the future, if you wanted to be able to verify that a document that hashes to a certain hash matches its proof, then you can do so at any time in the future with or without Tierion even being there. You can do that with open source client tools that we provide that you could download and keep forever, and the math always works. You just have to follow the recipe in order to get yourself back to the anchor on one of these public blockchains.
Cool. And so to what extent is Tierion kind of blockchain agnostic? Like the blockchain that lies underneath, my understanding was originally it was Bitcoin. And can you talk a little bit about like what the app requires the network to be?
Yeah, I can address that. So we are public blockchain agnostic from a technical standpoint. Since we do anchor all the incoming hashes to this internal intermediate abstraction called the calendar, And that's what's actually gets anchored to any public blockchains. You can think about it like an adapter between our calendar and any public blockchain. We've built adapters that will allow us to work with Bitcoin and Ethereum, but if something were to come along in the future that we felt offered some additional security guarantees or some other properties, it's not a really significant effort for us to add an additional adapter, and we could anchor to as many of those as we want to. It's really just limited by the fees and the utility of it.
Glenn, this might be a good opportunity to explain how we're using the data from Nist.
Sure. So one of the interesting things that we've incorporated in this new version is something called the Nist Randomness Beacon. So National Institutes of Standards and Technology has put out a service called the Randomness Beacon, where once every minute they generate a very high quality random value, a 512-bit random value. And they store that in their own lightweight blockchain type structure, and they publish that publicly along with a timestamp. So they'll say, you know, at this minute, we had this random value. At the next minute, we had this random value. And they hash link all of those together, and they sign them with a digital signature. And they make that available publicly. And so what that is an ever incrementing piece of random data that we could not have possibly known in advance. And we take that along with the UUID that I mentioned, and we mix that cryptographically when we SHA-256 the hash that you submit to us. We merge that with the UUID that we created for you, which has both random entropy as well as a timestamp. And we also merge that with the current value that we have for Nist. And so this proves that the hash that you submitted was submitted after Nist generated their timestamp. It's impossible for us to have incorporated their timestamp before that. On the other end of that spectrum, when you get back the proof, you'll receive a proof which anchors to our calendar and also to the Bitcoin and Ethereum blockchains, each of those entities have their own sense of time. Some of them are more accurate than others. The NTP timestamp that we'll give you initially is accurate to the millisecond, and we use Google's public NTP service for that. The Bitcoin and Ethereum blockchains have very different rules about timestamps of their blocks. Bitcoin, for example, can easily, the spec allows it to be off within hours. But what we can prove is that we give you a high precision timestamp, and on one end of the spectrum, we know we've submitted after Nist, and on the other end of the spectrum, we know we've submitted before a Bitcoin or Ethereum block. So you have this provable window of time, and what we're trying to do is get that window as narrow as we can, but our Nist time, our NTP time should always be somewhere right in the middle, and that's the one that we suggest you look most closely at because it's the most accurate.
Ah.
But you don't want to need to trust us. We want a trustless system. So you can say that our NTP time is the most accurate, but we can prove that it's within this window between Nist and the public blockchain times.
So that's really interesting. So how does the, you know, in trying to get that range, that provable range down, how is that impacted by, let's say, the block time of the underlying blockchain?
Yeah, so you could have a scenario where, for example, we give you a NTP timestamp of, let's say, noon UTC, and but the latest Nist value we have was, say, from 45 seconds ago. So you can provably say that you were very close to that Nist timestamp of when you submitted, but after it, which is the most important thing. We should never generate an NTP time, which is insane, if you will, and prior to the Nist timestamp. And we will make that guarantee internally, that we will not create a proof where our NTP time somehow theoretically got so out of whack that we were off from the Nist time. But it is possible if, for example, the Bitcoin blockchain is reporting block times that are 2 hours old, the Bitcoin block could actually not be a window like this with our NTP time in the middle. The Bitcoin block could now move before the Nist time. because it's actually gone back in time. So whenever you look at a proof, you have 3 or 4 sources of time information, and ultimately it's up to you to determine which one that you want to trust the most. The fact that we have this Nist time, which does only get generated once every minute, means for sure that we generated after that. But the public blockchains, Ethereum and Bitcoin, they can be off, and that's to be expected because the spec allows it. But there's no real way around that. But we can prove that you submitted after a certain time.
So I guess, like, if the underlying blockchain has a shorter block time, does that narrow the window?
No, because the block itself will contain a timestamp. It's just not guaranteed that that timestamp is actually accurate. For example, it's not guaranteed that it's in any way synced with any time service. It's just the block time is actually submitted by the miner of the block, and he controls that time that's submitted. If he wanted to submit a time that was totally that was an hour behind, he could do that, and the system would accept that block. Now, if it was outside of that window that Bitcoin accepts, then that block would be rejected. But there is a pretty loose window of time where the block would be accepted no matter what the time reported is. So that's just something we have to work around.
And so as you guys sort of develop this functionality across several underlying blockchains, like what, these systems, they tend to inherit the properties of the underlying blockchain. Like if you build a system on Bitcoin and that has a longer block time, like what you see with, for example, Blockstack and OneName, right, is it takes the block time to register an identity there. If you have a faster block time, it's faster. So how does going from like one blockchain to the other impact the user experience of Tierion, or does it at all?
I don't think it really does, because the primary thing that we're first anchoring to is this calendar internal to us, which is something, by the way, that we make publicly available, all the data in that calendar. It looks like a lightweight blockchain. Every record that's in there is available over a REST API, and we cryptographically sign each one, and each one is hash linked to the other. And that's actually a critical function that all of the nodes, which we'll get into, I'm sure, perform. They audit that chain. But as far as your question about what the effect of different block times, for example, has on us, none really, because our calendar is anchored every 10 seconds. Internally. And so we're continually building that chain, and we also mix in that Nist timestamp into that chain as it goes. And then when it's time for us, let's say, for example, if we were going to anchor to Bitcoin every 30 minutes, what happens is this adapter we talked about before grabs the state of our calendar chain and builds a Merkle tree of all of the calendar blocks that have been created since the last time we anchored to Bitcoin. So that could be some thousands of calendar blocks in our own internal system. And we build a Merkle root that contains the block hash of every one of those blocks. And that's what we actually submit to a Bitcoin. And then we wait and we monitor the transaction that includes that hash in an op return for Bitcoin. And we wait and we monitor that until it's received 6 confirmations. And then when it has, we take that data back and we anchor it again into our calendar. So there's a closed loop cycle that happens with all the data that comes into the calendar and then linking out to each public blockchain. And we do this process separately for both Bitcoin and Ethereum. So that even if it took longer than expected for a proof to come back, the only impact on our system is that the user would not get their Bitcoin locked proof until a later time. But it doesn't change the time that our calendar anchors it to, and it doesn't change the NTP timestamp that we gave you, and it doesn't change the Nist value that we incorporated into that proof.
And Jake, from a developer and from a product perspective, this was really important to us. When we first built Tierion, we had to wait up to 10 minutes because we were putting a transaction into every block. But being able to get something back right away was a feature that our customers really wanted. And to be honest, some of our competitors, competing technologies in the world, were holding over us, at least initially, as a young startup. There's a company called GuardTime, which makes some technology that is a little bit similar to ours. And they were saying, well, Tierion is cool and it does some interesting things, but you can't trust the blockchain and it takes too long to return a proof. So a lot of what we're doing with the technology and the things that we're implementing today is addressing some of those problems that we heard from our customers and from our competitors.
Mm-hmm. So that's interesting. You're kind of confirming what is fairly well known from the user experience point of view in a lot of blockchain products, right? That time to execute commands matters. The friction on the front end and the UI matters, especially when you're talking about kind of enterprise clients and things like that. So just a quick question here, which is technical, but it's meant to lead into kind of a better understanding of what is decentralized and what is centralized here. So when you talk about the calendar chain, is that a public decentralized network, or is that something that you run kind of internally?
Sure. So the way that the calendar works from a decentralization standpoint is we have what we call the core, right? And the core is a cluster of servers that we operate. So for example, we have the first 3 clusters up and running today that are in operational testing now. These are all, highly modern applications. We heavily utilize Docker and Kubernetes, and these 3 zones, if you will, are in 3 different availability zones of our data, of our service provider. So they're geographically and data isolated from each other. You can submit to any one of them from a node independently. But each of these core members, and we'll have partners that will join the core as well. One of them that we've talked about is Microsoft intends to join this core network to be one of those core operators. Each of the core operators are the ones that have the ability to write to the calendar, and they also have the ability to anchor to the public blockchains and spend the fees to anchor to the public blockchains. So the way the calendar itself works, I've already explained that we make the data in the calendar publicly available, but that's a read-only copy that anybody can audit and mirror. But when it's time to write something, so when our calendar has finished, when our aggregators have finished building up a Merkle root and we need to write something to our calendar, we need to make sure that only one of those core clusters can write to that chain at any one time so that we don't introduce a fork into the chain. So the way we do that is through a leadership election using the Raft protocol. Specifically, we use software called Consul from HashiCorp. And we elect a leader instantaneously out of one of those core members, and they are given exclusive write access to that calendar database. And the calendar database uses something called CockroachDB, which is a decentralized database that's designed to operate across data centers, across geographies around the world, and be a consensus database. And this actually came out of the people at Google who created Google's Spanner product. So it's some of the same people who did that. Yeah.
Just about Spanner. Spanner is Google's internally developed distributed database that is the foundation of all of Google's infrastructure.
Yes, but it only runs within Google.
Yes, not anymore.
Well, kind of, yeah, with CockroachDB, yeah. Any of the core cluster members that want to write, they ask for write access and they're given that write access. But we only allow the core cluster members that are, these are considered permissioned entities, to write to that database. But the data itself is fully decentralized because this concept of nodes that we have, the nodes are an outer ring that run around the core. And the nodes are critical to our ability to scale. So let me just briefly examine what a node does. So a node performs two primary functions. One is to be an auditor of the core data. So continuously, 24/7, the node is asking for the latest calendar blocks from the core. And it pulls those down and individually examines them, recalculates the block hash on it, verifies that the signature, the public key signature that a core member has signed with, correctly verifies that entry. And it also makes sure that each block that it retrieves is hash linked correctly to the prior in the chain. So we have a full chain. It does that for every block, but also periodically it will go and audit the entire chain copy that it has. So if we have 1,000 nodes that are operating out there, then each one of those nodes would have a full copy of this calendar. And then the node provides the ability for clients to connect directly to it. So the node has a copy of the same REST API that core does. So you can submit hashes to it. You can ask it to verify a proof. You can retrieve proofs from it. And so each one of the nodes can handle thousands of hashes per second. They, every 1 second, build their own Merkle tree. That Merkle root is then submitted to core. So if you think about that, 1,000 hashes per second, 1,000 nodes, that's 1,000,000 hashes per second that outer ring can handle. But all that's being sent to core is 1,000 hashes per second. And we, to give you a sense of our scale, I have personally tested our core infrastructure to handle hundreds of thousands of incoming hashes per second. So we can absorb a lot of hashes from a lot of nodes. And we'll get into the TNT mechanics, but from a technical standpoint, it is critical for us to have as many of these nodes as we can so we can handle the really high volumes of hashing that we envision our ability to do.
So that's really, sorry, go ahead, Wayne.
I just wanted to emphasize that, based on the latest data that we have from that Factom has published, their network can handle about 47 transactions per second. And so we're doing things a little bit differently, and we can talk about that later because that question comes up quite often. But what we're doing is orders and orders of magnitude faster and more scalable than any of the competitors out there that we're commonly compared to.
Mm-hmm. Awesome. So it sounds like you guys are building some pretty interesting distributed technology. I want to make sure we also cover sort of the business side of this and the fundraising side. But before we get there, just like very quickly, so how much of this is open source and how much of this is dependent on kind of your centralized company, right? So you mentioned you have these core nodes that are permissioned and managed by your company. I guess my question is like, could someone take your code base and instantiate another Tierion network if they wanted to, or is there pieces of the network that are proprietary and for profit that you're keeping to yourselves?
So all the software is going to be released on open source licenses. So it's going to be fully out there and available. But back to what you just said about could somebody else fork this and do something different? If you look at Bitcoin, there's nothing stopping anybody from forking Bitcoin and doing something different. In fact, we've seen it thousands of times. That's where the initial generation of altcoins came from. But network effects are real. And we have a customer base. And once we've built something up that has a significant volume of people on it, I think it would be pretty difficult for other people to catch up to us and be able to build something. The other thing is that operating this core and actually anchoring into Bitcoin and Ethereum is expensive. It used to not be. When we first started doing this back in 2015, it was about 3 cents for a Bitcoin transaction. Now it's like $3.50. So if you're doing a transaction every few minutes, you could spend hundreds of thousands of dollars per year. So if you wanted to run this all by yourself, you have to bear all of that cost. Furthermore, the system that we've created has a global calendar. This is this lightweight blockchain that Glenn was talking about. Anybody with that global calendar can verify any proof that was generated by the system. So if you start to fragment the network and you start to build up others, you could have these chain point proofs that we generate that would not necessarily be verifiable to the calendar level. So, so while we can't really prevent people from doing things, we think it's going to make the most sense for people to join the network that we're building and that we've scaled out and that we're maintaining and growing and adding things onto. And the other thing that's worth mentioning right now is that this core service of anchoring data to the blockchain, supplying a trust anchor and a globally verifiable timestamp, is really like what we consider a foundational proof engine, a foundational technology that we're going to be using to build other services that we're not going to talk about yet because we kind of want to get this out there and tell people about what we're doing today. But this is not the end of the road for us. This is the beginning of something that we're building that's going to be big and significant.
Awesome, thank you. So moving on to more of the market opportunity here. Is this kind of functionality of being able to basically, trust anchoring for various applications, is this something that companies in the marketplace in various verticals kind of already have in some form as a service, and this is making that more efficient? Or is this providing a completely new sort of technology platform to do things that they weren't able to do before?
It's a little bit of both. So if you look into companies, industries like insurance, for example, they actually have data integrity specialists. So people who are responsible for protecting the integrity of the records inside their systems. And they also have vendors who supply data integrity products. These are companies like EMC and Dell and others who have these types of services for backing up and verifying the integrity of your information. On the other end of the spectrum, you have companies like GuardTime. That's probably the biggest company in the space. They started around in 2007, I believe, and they billed themselves as being the first blockchain company, even though Bitcoin wasn't invented yet. They provide services to government, defense, financial services. They're really focused on cybersecurity and being able to monitor the assets inside a company and being able to detect when those assets have been modified and helping you make sure that you can track that down. So for example, if you had a bunch of bank records, GuardTime would be used to monitor what's going on in the database, in the core security assets like the config files and other parts of their IT infrastructure to be able to detect when something has happened. And then they can prove that that integrity information has been compromised. So there's an existing marketplace that's fairly large and mature for data integrity and timestamping, but oftentimes it's baked into other services. People just don't go out and buy a timestamping service typically, although that's what GuardTime and a few other SaaS companies provide. Now, the part that's new is that with all of this infrastructure that's always existed historically, you always had to trust the provider. You always had to trust the person who was issuing this timestamp to you. And there was really no way to be able to create a trust anchor or be able to create a timestamp that was globally verifiable against a network that somebody else had an economic incentive to persist. And that's what's different now. So all the companies that you hear in the blockchain space who are talking about identity, like Blockstack and Civic and others, what they're doing is basically building registries of individuals that are cryptographically linked to an entry on the Bitcoin or Ethereum blockchain, and then issuing claims that are digitally signed by that entity that are also anchored and timestamped into the blockchain. So all of that activity is driven off of the same technology. Now, we think we have the best technology in that space by far in terms of being able to anchor data and generate these kinds of proofs. And we have some of the companies that are in that identity infrastructure industry are actually working with our technology. And we formed something with Microsoft and 20 other companies called the Decentralized Identity Foundation, which you can, if your listeners are interested, they can go to identity.foundation and learn more about that. But this is a very fundamental basic technology that is going to enable us to build a new, more secure internet, new types of applications where the root of trust is not in certificate authorities or other types of trust entities. It's basically that basic trust dial tone is going to be baked into the internet itself. And that's really what we're looking to build here.
Awesome. Cool. Thank you for that. So I'd love to now move over to the TNT, the Tierion network token. But before we dive in there, so Wayne, in the past, it sounds like you have been a bit skeptical of Ethereum, to the point that there's a Pete Rizzo article on CoinDesk recently that says, no joke, blockchain startup Tierion to seek 25 million in Ethereum token sales, and goes on to say that whereas you have been initially skeptical about Ethereum and ICOs, you are now running an ICO yourself. So can you tell us a little bit about like the process that you went through in terms of understanding the technologies in the market and kind of coming around to Ethereum as both a platform and a method of fundraising for your project? Sure,
that's a good question. So people who know me know I have a long history in the industry. Started really publicly doing things back in 2014 with the launch of a company called Coindera, which was a Bitcoin alert service that I had built with one of my friends. Was involved in the first storage project a little bit, and pretty heavily involved in the launch of Factom. So I designed the Factom Explorer, and I helped them build their product and execute the crowd sale initially. I also introduced something called Wayne Chain, which was making fun of all of the blockchain hype about a year ago, really. It was I think that Wayne Chain launched in like February or March of 2016. And really what bothered me was that there was this huge disconnect between what you could actually deliver and what the hype was. I mean, back then, everybody was talking about putting everything on the blockchain, music and land titles and food provenance. You know, you're going to track how your fish got to your plate by, scanning it and looking it up in Ethereum. But there was never any practical discussion around, do these things scale? Does this make any business sense? Why would we do this in the first place? And so I created Wayne Chain because back then, if you weren't a true believer, if you didn't like smoke the blockchain hype, you were a Luddite. You didn't get it. And there were a lot of people who were overpromising. So I was very skeptical of things back then. I thought people should be more realistic. I'll give you a practical example. I was a judge at the Consensus Hackathon in 2016, and there was a team that talked about doing blockchain voting. Voting was obviously hot because we're in an election year. And they were recording every vote directly in Ethereum. And I'm like, well, how can that scale? I said, we're here in New York. There'd be a couple million votes cast just in the state of New York. Ethereum takes, graciously maybe 20 transactions per second. It's really more like 12 to 15. So I did some back of the napkin math, and it was going to be several months and several $100,000 just to record the votes, assuming a single operation. And it didn't even faze the other judges. It wasn't even a factor in their consideration for whether or not this was practical. So there's this, just an example of this huge gap. The other thing that's been very different is that the early companies that wanted to do token sales, they had to build their own token infrastructure and their own blockchain. So that took away a ton of time and energy for them actually being able to execute their own project and actually deliver value. So, Factom's a great example of this. I still don't think they have a wallet for their software. And actually, they do, but it's like a web-based wallet. But it was very crude, and there's been a lot of time and energy put into building their own token, whereas all the people who are doing things on the ERC-20 standard are able to leverage all of the engineering and all of the effort that's been put into the infrastructure around wallets and exchanges and token sales. Another factor is that a lot in the world has changed. So in the time period from, let's say, January of 2015 until now, we've seen billions of dollars flowing into companies and projects through these token sales. Our lead investor, Blockchain Capital, for our seed round, did a token sale to raise 10 out of 50 million for its venture fund. And I joined as an advisor on the advisory board of Blockchain Capital earlier this year, and am involved with lots of startups. And I see things from both sides of the table, both the founder and on the investor side. And there's just a huge wave of these tokens that are coming in. And it is all the law firms like Cooley and Perkins Coie, and the accounting firms like Deloitte and Accenture. They're all in on putting together a well-defined, regulatory compliant structure that is much, much lower risk and doesn't involve a lot of the shady things that I saw personally back in the early days when I was involved with some other, or present at some other token sales. So when you add all of this up together, you can see that there's a very different environment. And I would be foolish not to change my mind. I would be foolish not to accept this new reality that we're in, where it says, hey, my lead investor did a token sale. The other companies in the portfolio are doing token sales. I have everybody calling me up on the phone who I've been talking to about doing a Series A round saying, is there a token element to your project and how can you make this scale? And the fact that we've been working since January on this and I have a yes answer for that is a huge plus in their mind. And another thing that's happening is that to some degree, early stage investors, at least here in Silicon Valley area, are interested in companies with tokens because it provides liquidity for them. And they see how tokens accelerate network effects. I have other people coming to me saying, how can I bolt a token onto my company in order to make it investable? Which is a damn shame, to be quite honest, because some of these founders are absolute rock stars and they're not getting the attention that they should be because they don't have this element. It doesn't make sense for their business. So for us being an infrastructure-oriented company and having something where we have to provide an economic incentive for these nodes to run and for being able to audit what Core is doing, that makes a lot of sense. You couldn't do those payments in Bitcoin. If we're running 1,000 nodes, we can't pay 1,000 Bitcoin transactions every so often. That's going to cost us a fortune. So people have often criticized, well, why don't you just do this with Bitcoin? If you do it for the same reason you can't buy coffee with Bitcoin. It doesn't make any sense. You also have to have an economic incentive and some sort of way to protect against like Sybil attacks. So for example, for a node to fully participate in the network, they have to maintain a certain minimum balance of Tierion network tokens, TNT, in order for them to actually be eligible to receive that reward. So there's a whole host of things that we're doing to try to make it so that there's an economic incentive for the network to persist, and that whole thing can operate in a way that is efficient and provides people with very strong guarantees that is going to continue to grow and continue to be available. And a lot of that couldn't exist without the ERC20 standard, the exchange infrastructure, a lot of the regulatory and legal matters that have gotten, they've gone from being completely uncertain to being gray area. Let's put it that way. And we're going to probably see some more refinements on that coming. We've seen things go from, selling tokens to 16-year-olds who hang out on Bitcoin Talk and Reddit to professional investors and family offices. I know because I see inside some of these other deals, about 75 to 80% of the dollars that are coming into these deals are coming from professional accredited investors, not from individuals. And then on the utility token side, I think there are some that are definitely positioning themselves as securities and being invested in owning a stake of that entity. But on the utility side, I think that protocols like ours are starting to get some clarity around the utility and the usage of the token and the issuance and the marketplace dynamics. And despite what some people wish would happen, this is not going to go away. Bitcoin is not going to be the only blockchain. There is blockchain ain't what it used to be. That's what I've been popularizing. There's a little meme floating around the internet about that. And people who have been adamantly against this, they need to learn. They need to accept new information. I get a little bit more of it than they have, but I think that they'll see very soon, by the end of the year, I think attitudes are going to very much change. People should be still skeptical and not just accept things. There's going to be a lot of hype, a lot of a lot of bad use of capital, just like we see in every tech bubble. Like I saw in the tech bubble and the dot-com boom when I first started working in the industry. But I think this is definitely here to stay.
Awesome. Thank you, Wayne, for that view. And I think I really appreciate it. And our community certainly values, kind of a scientific approach where we modify our views based on sort of data-driven considerations. And I also totally agree with you that I think people vastly underestimate the scalability risks in Ethereum, things like that. They in the past have vastly underestimated the value of the network effect of a compatible infrastructure around a blockchain, and having a relatively simple programming language, which is not perfect, but yet is accessible to tens of thousands of developers and makes the barrier to entry a lot lower. And certainly token sales, while you cannot say that the vast majority of them have been phenomenal successes or even proven yet, and some of them have been outright less than ideally kind of not great projects. I think this is definitely paving.
Scam is a four-letter word, but you can say it.
I don't like to use the word scam because it's like, to me that implies like very clear intentions to steal money, and that's not actually, I think, what's going on with a I don't know if a majority, but with many different sales. I think what more commonly happens is that you have a team that's just not building great products. Mm-hmm. And it's not a scam kind of in the theft sense. It's a scam in the sense of like, you're just kind of investing in something that's not great, people are
taking millions of dollars on a white paper and a promise. Right. We're very proud that we have something that exists and it works, and we have a track record of using it with customers. Right. And we're going to be ready on day one to be able to have people using this technology. That's very different than what other people have been able to accomplish.
Absolutely. And we at CoinFund have also taken some great care, to take on clients that are in that boat, people who have existing revenue generating businesses, or at least like very good prospects in an existing industry. But before we go down that rabbit hole, I want to make sure we talk about TNT, as we're sort of running short on time here. Tell us a little bit about what the Tierion network token does on the platform and how your fundraising will utilize it.
Sure, I'll go through that real briefly. So people don't run computers for free. There is a cost for anchoring into Bitcoin. There's a cost for running the servers, and there's a cost to everybody who runs a node. And so those people have to be economically compensated. They have to be motivated to actually run that infrastructure. And that is the primary use of the Tierion token, is to provide the economic incentive and some of the security mechanisms to make sure that that network is robust and that everybody inside that network has an incentive and an economic incentive in order to maintain that network. So, for example, core nodes, the part of the core, they have to anchor data into Bitcoin and to Ethereum. That's going to cost, tens to hundreds of thousands of dollars per year, and it's only going to go up over time. We see that increasing, fairly dramatically, and a lot of people in the industry agree that those transaction fees, even with SegWit, are going to continue to rise. Now, these nodes that mirror the calendar, that lightweight blockchain that we generate, they have to have a reason to do that. And we need an incentive for people to persist that, because every node on our network increases the scale of what we can, proofs that we can generate. And it also provides a geographically distributed, highly reliable, distributed network of computers where these proofs can be verified. That's really important. You want to make sure that every proof that was generated by the system can be verified by a global network of nodes. And so, the use of the Tierion network token is to be able to, the nodes use it to be able to pay, to create a small economic incentive, economic instrument for them to pay to anchor data. And then also they receive a reward for mirroring this calendar and being audited periodically. So we check to make sure that They have an open API endpoint that allows proofs to be verified. And for doing that, they receive a reward. Now, in the future, there's also a minimum balance of TNT that will be small initially. It will be like the similar amount of money to what you would have for like a mid-range graphics card. This just prevents people from spinning up nodes willy-nilly and trying to milk all of the rewards that come out of the program. Glenn, you want to talk a little bit about the process of auditing the nodes and
Sure.
how that works technically?
Sure. So as I mentioned earlier, each node is continually pulling down a copy of the entire calendar blockchain and verifying every block on there. As part of the audit mechanism, Core will reach out to every node periodically. So say, for example, once an hour, Core would reach out to each node and query its state. So we're checking, as Wayne mentioned, whether or not it's publicly available, because only publicly available nodes which are providing extra value to the service would be eligible for receiving TNT rewards. We also check that the timestamp that the node is serving is within tolerances of the core timestamp. We don't want somebody be running a node on a PC that has a dead clock battery and is serving times in 1943. And we also will periodically, we generate a cryptographic nonce on the server side. And every node is required to pull down that cryptographic nonce and build a Merkle tree where the nonce is the first leaf of that Merkle tree. And then we add in every calendar block that they have mirrored, the block hash of every calendar block that they've mirrored into that Merkle tree. And we come up with a Merkle root. And so that root represents this is a challenge response mechanism where we can provide a nonce, and they need to prove that they have all of the calendar data that is current and accurate from core, and that they can match it on the node side. They calculate that response, and they make that available over their public API. So when we ping them to see whether or not their site is available, we also look for this calculated value and compare it to the one that the server has calculated to say, is this node serving accurate and current data? If any of those criteria are not passed for the reward period, then the node will not be eligible to receive its reward. So they would only be paying TNT to core in order to perform hashing functions, but they don't get any other reward unless they're operating a public and verifiable node.
Awesome. Guys, thank you very much for joining, and thank you for that information. Where should the viewers go to learn more about Tierion and the upcoming fundraising that you guys are doing?
Sure. The best way is just to go to our website, Tierion.com, Tierion.com. If you're interested in learning about the token sale, there's a link right up at the top of the homepage. You can also follow us on Twitter, and we have a regularly publish information in our blog. And there's some technical detail on our token sale page. There's a white paper, a document about the token. There's a blog post about Chainpoint, this protocol that we've created, and that provides some more technical information. So you can do a real deep dive by visiting our website, looking at our blog, and also just follow us on Twitter. We're going to be talking a lot more about what we're doing in the coming days as we get past the token sale deadline.
Awesome, fantastic. Well, once again, thank you very much for your time and for coming on. And best of luck with the product, and look forward to following your progress there.
Thank you very much, Jake.
Bye-bye.
Cool. Thank you.